Hello everyone, my name is Manohar. I'm a data science trainer and consultant. Today I'm going to explain about linear regression algorithm and also we will see how to implement linear regression algorithm. This linear regression algorithm is used to predict the continuous variables like house price prediction, car price prediction. Without any further delay, let me tell you agenda for this discussion. Firstly, I will explain what is algorithm and the difference between algorithm and the program. After that, I will give you a brief introduction to linear regression algorithm. After that, I will explain the statistical key terms like variance, covariance, slope, intercept, and error rate. Later, we will see the implementation of linear regression in a Jupyter notebook. Let me explain what is algorithm and the difference between algorithm and program. Algorithm is a predefined program. It is finite. We write the algorithm and store that in a separate folder. Whenever we want, we just import that and can be used. And come to the program. Program is a finite. Program is built with a set of instructions. With those instructions, we write the algorithm. I hope everyone is understand the difference between the algorithm and program. Let me move forward and let me explain about linear regression. Regression is a supervised machine learning technique which helps in finding the correlation between the variables and enables us to predict the continuous output variable based on the one or more predictor variables. You can observe the red color points, those are called data points, and the blue color line is called a regressor line. And let me explain the graphical representation of the data. We have to take dependent variable on y-axis. Here, dependent variable means our target, and take the independent variable on x-axis. We plot the data, then that gives us some points. Those points are called the data points. The black color, there are some points. Those points are called the data points. If I draw a line through all the middle of the lines, then we call that line as a regressor line. This is the representation plot for the correlation as well. Let me explain types of regressions. Regression is categorized into two types based on number of independent variables. If we have only one independent variable, then we call that as simple linear regression. If we have two or more number of variables, then we call that as multiple linear regression. Let me explain about the simple linear regression and its formulas. I already told you when we have only one independent variable, then we call that as simple linear regression. Here the formula for simple linear regression is y equal to m multiplication of x plus c. Here y indicates that target. What we are going to predict something that is y, and m indicates the slope. Slope is inclination to our regressor line by taking the reference as y-axis, and x indicated each element from independent variable, and c indicates the intercept. Let me explain about slope. Slope is indicated with the letter m. It is the ratio between the rise and run. Manually, we calculate the slope by using any two data points. Each data point has x and y. We calculate the rise as y2 minus y1 and run as x2 minus x1. But in a real time, we get bunch of data points. Then how we will be able to calculate the slope? How can I select the two data points? With this procedure, calculation of slope and drawing a regressor line is difficult. So I will explain the procedure to calculate the slope. But before going to explain about the slope, let me explain the variance and the covariance. Covariance is also known as correlation. We check the correlation between the independent variable and dependent variable. Either it is a positive correlation or negative correlation. Let me give you one example to understand the correlation. Consider the height and the weight. If weight is increases, then how height is moving. If weight and height, those are increasing, then we confirm that there is a positive correlation. If weight is increasing, then height is decreasing, then we consider that there is a negative correlation. Otherwise, we confirm there is no correlation. To calculate the covariance or correlation, there is a formula, that is x minus mean of x multiplication of y minus mean of y. We take the summation of that and we divide the value with the total number of samples and come to the variance. Variance will give you the results as spread of the data points from the mean. If we get large difference between the sample to sample, then we may get low accuracy. So we have to check the variance. To calculate the variance, we subtract the elements from the independent variables and mean of that sample and square that, take the summation, divide the value with the total number of samples, and now come to the slope and intercept. To calculate the slope from the covariance and the variance, we divide the covariance with the variance. Then we get the inclination of a regressor line and come to the intercept. Intercept is the interaction between the y-axis to the regressor line. We calculate intercept by subtracting the mean of y and the multiplication of slope and mean of x. Now come to calculate the residuals. Residual is also known as error. We calculate the error by subtracting the actual values and predicted values. After predicting the values, we may get different values. There is some error. We calculate that. In the image, you can observe there are some data points. We draw a line through all the mid of the lines. We calculate the point to the line. There is a difference. That difference is called error. To calculate the errors and all, there are some methods like sum of squared error, mean squared error, least squared error. Let us see those methods. By using summation of square method, just we take the summation of all the errors. That is our error rate. And by using the mean squared method, just we take the mean of all the errors, and by using least square method, we consider the minimum value from the error, right? And come to the multiple linear regressions. If the features are increased, then slopes also will increase. It is same as simple linear regression. How many independent variables are there based on number of slopes will come. Now let us see the implementation of linear regression. In real time, we make a bunch of data. By using predicted and actual values, we plot the graph as shown in the slide. Now let me open the Jupyter notebook. Yes. Now we are going to implement linear regression algorithm on the car price predictions. Here, first understand the problem statement. A Chinese automobile company Geely Auto aspires to enter into the US market by setting up their manufacturing unit there and producing cars locally to give the competition to their US and the European. Here, the Chinese automobile companies wants to expand their business and give the competition to the US market as well. Before going to expand their business in the US, the Chinese need to know the standards of US market as well, because Chinese market standard is different and US market standard is different. Based on what kind of features they are deciding the price. The US persons are deciding the price based on what features. Chinese need to know that. So in our implementation, we are going to give the features and which features they are going to decide the price. Right, this is our actual goal. Now let me import the data. Here I am using the pandas library to import the data. From that library I am just taking read CSV function. In the read CSV function, I just passed my path and I imported the data. Here this is my data. In the data you can observe the features like car ID, symbolic, car name, fuel type, aspiration, door numbers, car body, drive wheel, and many more columns are there. If you want to see what are the columns are there in our data, just use this code and whatever the variable name you have taken, while storing the data into the name, just use that name. Here I use the df. In this variable name I stored my data. Just use that df and next use the columns. Then you will get all the column names which are on the data. You will get all the column names. Later you can decide any kind of pre-processing and analysis and all after looking into the column names. Right. Here the column names are car ID, symboling, core name, field type, aspiration, door number, car body, and many columns are there. Till to 26 columns are there. Here you can observe. 205 rows are there and 26 columns are there. Right. Now let me start the data pre-processing. Here first I am going to drop the car ID because remember in the machine learning the ID number and the name will not give you any kind of results. So that is better to drop that kind of features. So that is the reason I am going to drop the car ID. Here after dropping the car ID, I am storing my entire data into the data variable name. See, after dropping the car ID, there is no car ID in our data. Like just the data is like symboling, core name, field type, aspiration, and many more came, right? And now come to check, is there any null value in the data? I'm checking the null values in the data by using this code data.isNull.sum. Here in symboling there is no null values. It is giving 0 nulls. And the car name there is no null, and here you can observe nowhere it is showing any kind of value. It is showing the value as 0. 0 means there is no null value. So we don't need to worry about the null values and all. Now come to check for the punctuations in the data. Is there any question mark? Is there any exclamatory mark? Is there any empty spaces in the data? We have to check that. Right. Here from the string.punctuation, I am gathering all the punctuations. By taking one by one punctuation, I am checking in each column, is there any punctuation mark or not. Right. Here you can observe it is giving 0, 0, 0 values because there is no punctuation mark. No punctuation mark, no. In any column, any punctuation mark is not there. No punctuation mark is not there. Yes, there is no punctuation mark and there is no null value. We don't need to bother about those things because they are not available in our data set. And now just observe this data set. Here in the data there is a car name. I want to know how many car names are there. I don't want the models, just I want the car names. Like here you can observe there is Volvo 144 EA, Volvo 244 GL. These kinds of models are there. I don't want the models, just I want the company names. Like there, the Volvo and Audi. I just want to know about the companies, how many companies are there in our data set. Right. To know that, here I am calling that feature name data.core and I'm splitting the spaces. Wherever the space is there at that moment, I'm splitting that into 2 or more number of elements. Here when I split the cell with a space, Volvo will come as a different one and 145E will come as a different one, right? And Volvo will come in our first index. So I'm going to take that str.get of 0. Just I'm taking this Volvo itself. I'm removing 145E and all, right? After taking that, I'm going to make that in uppercase. And after taking the core names and all, I'm assigning that data to our data under the name of brand. See, after assigning the core names, see the brand name key, the Alfa Romeo, Audi, Volvo, these kinds of core names came to our picture, right? And see how many brands are there. Here, pt.value counts will give you how many Toyota cars are there, how many Nissan brands are there, how many Mazda brands are there. It will give you the results like this. Here, the Toyota cars are 31 and the Nissan cars are 18 and the Mazda cars are 15. Let us see how many brands are there. Here Toyota, Nissan, Mazda, Honda, Volvo, these kinds of car are came. How many models are there like this? Let us see. Here, totally 27 brands are there. Here I use the set function to remove the duplicates from our data. Here, Toyota cars are 31. It removes the 30 because 30 are duplicate to the Toyota and it removes only one. It removes all the duplicate which are repeated many times. It will just consider one time and it will give you the results. Here totally 27 brands are there in our data. And let me represent this value counts in the graphical format. Here, yes, the Toyota cars are more than 30. In the previous cell, we have seen Toyota cars are 31 are there. And the Nissan and the Mazda and Honda cars are there. Highly Toyota cars are there in our data set. That means US market is using the Toyota cars very high. Right. Here if you come to the last, there is Mazda, VW, Porsche, Volkswagen and Toyota is there. Just a spelling mistake. So they are gone as a separate one. Let me replace VW as the Volkswagen and Mazda as Mazda. Let me replace that one. Here I'm going to replace wherever the VW is there and wherever the Volkswagen is there, I'm going to replace as Volkswagen. And wherever the Mazda is there, I'm going to replace that as Mazda. And wherever the Porsche is there, I'm going to replace that as Porsche. Right. And wherever the Toyota is there, and I'm going to replace that as Toyota. Right. After replacing the things and all, see 22 brands are okay. Totally we have 22 brands of the cars. Right. And now let me represent it in a graphical format. See here, totally 22 brands are there. In that 22 brands, Toyota cars are very high and the Nissan cars are in between the 15 to 20 cars are there, and the Mazda, there is no Mazda and VW and all because we replaced that one. Right. Now I am going to take the mean of the prices. What is the average price of the Toyota cars and what is the average price of Nissan car? I want to check that. Right. Here just I use a brand and the price and I'm going to take the mean based on the brand. Right. Here you can observe on the x-axis I have taken the brand and the y-axis I have taken the average price. Alfa Romeo average price is in between the 15,000 to 20,000 and Audi cars average price is near to 18,000 and all. In this way it will give you the average price. Now I am going to assign this average price to our data, so that is the reason I am going to merge our data based on the brand. Here after merging the data, you can observe the results. Here the actually we have a price that is divided into the price X and the brand price is divided as price Y. Let me rename to this price X as price and price Y as brand price. Here I'm going to rename to the columns price X as price and the price Y as the brand price. After replacing, you can observe the data, the price came and the brand price came. Right. Now let me assign what are the mid-range cards, what are the budget cards, what are the luxury cards based on the average brand prices. Right. Here I'm going to assign whatever the price of the car is less than 10,000, I'm going to give the name as budget cards. If the average price of the car in between the 10,000 to 20,000, I'm going to give the name as the mid-range cards. If exceed 20,000, then I'm going to give the name as the luxury cards. and I'm going to place that into the brand category, and I'm assigning that brand category to our data. Right, here the brand category key. Most of the cars are the mid-range cars. Right, here in our data there is a city mile per gallon and highway mile per gallon are there. These two are mileages. Chinese, sorry, the US market measures the mileage in the miles per gallon. Here they taken the city mile per gallon and highway mile per gallon. I'm going to take the mean of those and I'm placing that data into the mileage, and I'm going to assign that data to our data by assigning the name as mileage. Here I want to check if price is increasing, how the mileage is deviating. Just I want to check that based on the brand category. Here you can observe I have taken the mileage on x-axis and the price on y-axis. Here the orange color points are called the luxury cars, and the blue color points are called the mid-range cars, and the green color points are called the budget cars. Right, here whenever the mileage is increasing, the price of the car is decreasing. Whenever the mileage is decreasing, the price of the car is increasing. I'm getting this kinds of information from this plot. Right, now I'm going to check the correlation between the each variable, how one variable is increasing and how one more variable is decreasing or increasing. Just I want to know that. Here the data.core, I'm going to check for the correlation, and I'm going to represent that into the graphical format by using the heat map and all. Right, here the correlation is in between the symbolic and the mileage. There is no correlation, and symbolic to the brand price there is a little bit correlation is there, and the symbolic to the price there is a negative correlation is there. In this way I plotted this correlation plot. Based on these correlations and all, I take a threshold as the 0.75. Wherever the correlation is above 0.75, I'm going to select that feature. Otherwise, I'm going to drop that feature. Based on this heat map and all, I selected 16 features out of 26 features. Right. I'm going to train my model based on these features. Right. Here, see, just check whether I have taken the best features or not, just by checking the correlation and all. Here if you observe any plot in this graph, if you observe any plot, there is some kind of correlation, either the positive or negative. So we selected the right features. Right, and here if you observe in our data, there are some characters. Remember, our machine learning can't deal with the characters. It deals with only numerical values. So we have to convert this characters into the numerical values. Right. So that is the reason I am going to perform the label encoder. This label encoder will convert the characters into the numerical data type. And one more thing, that here if you observe, the value is 88.6 and here the value is 9.0, and in the same column if you observe, the value is very high, 109. So with this the variance may increase and the accuracy may get low. So that is the reason I am going to perform the scaling on this data to place the values in between the 0 and 1. Right, I'm going to perform the min max scalar on that to place the values from the range of 0 to 1. Right, after checking the car.info in the data type, if you observe the data type, all the things are converted into the numerical data type. The either integer or the float, all things are converted into the numerical data type, and there is no null value. Right, and I'm going to check the variance of the data. Here the variance is very less because the exponential value came. The variance is very less, so we don't bother about the variance and all. Now I'm going to divide my independent variable and dependent variable. I placed my dependent variable on y-axis, I have taken and I stored the dependent variable into the y variable name, and I am taking the independent variables in the variable name x. With these two things, I am going to split my data into train data and test data. Right. Here I splitted my entire data into the train data and test data. Now I am going to import my model. There is linear regression from the linear model. Here I am training my data by using the fit function. Inside the fit function, I am going to pass the arguments as our training data set, that is x train and y train. From there, after training, I'm going to predict the values. I'm storing those values into the pred variable name, right? And now I'm going to check the accuracy of our predicted and actual values. We got the accuracy as the 82%, right? And the length of y-test I'm checking to plot the graph between the predicted values and the actual values. If you observe the graph, almost all we reached. Here the actual values are indicated with the blue color and the predicted values are indicated with the orange colors. Almost all we reached our predicted values. We got the best accuracy, right? And now if I plot a regression plot between the predicted values and the actual values, the plot is look like this. And if you check the correlation between the predicted values and the actual values, I got the correlation as the 93, right? Here taking the accuracy and taking the correlation is not our goal, right? What is our goal? We have to give the right features to the Chinese market. Based on what features they are deciding the price, based on what features the US market is deciding, we have to give that feature to the Chinese market. That is our actual goal, right? Here I am going to train my model by using the OLS model. That is, here the OLS is nothing but order least square. It will check is that feature is giving high error rate or not. If the feature is giving high error rate, we are going to drag that. Just by training this, it will give you whether the feature is suitable for our good prediction or not. It will give you the results like this. If you observe in the summary, the p-test, here it will consider the significance value. If these values are below the 0.05, we are going to select those. If the feature is exceeded above 0.05, we are going to trap that, right? Here if you observe the p-value, our significance values and all, here 0.86 is more, that is curve weight, right? We are going to drop this feature curve weight, and again we have to train our model by removing the curve weight and all. Again we have to check for the p-value, right? Here the 0.57 is exceeded more than 0.05, and is there any 721? No, this is the one. Mileage is the highest one, so we are going to select that and we are going to drop that, and again we have to train our model, right? sm.ols, again we have with that, again we are going to train our model. Again check for the summary. In that summary, is there any value is exceeded the 0.05, select the maximum one and drop that, right? Here 0.604, and this is the highest one, that is curve length. We are going to drop that and again we train our model. And in the same way, until we get the p value below the 0.05, we are going to find that and we are going to drop that and we are train our model, right? Here in the last, if you observe, here, yes, after removing all the features which are giving the p-value as 0.05. We are going to drop that. We drop that. After dropping, all the features are below the 0.05, right? These are the right features. Now I am going to calculate the variance inflation factor. This variance inflation factor takes two arguments. First one is the exoc and the second one is the exoc index, right? Here the exoc will find the variance in the data, if is that feature is giving high variance or not. That will take the data like that. And the exoc index will check for the multicollinearity in the data. Is there any correlation between the variable to variable? It will check for the correlation and all. After checking all those things, it will give you the variance inflation factor value. If that value is above the 5, then we don't consider that feature. If the variance inflation factor is below the 5, then we are going to select that feature. Here the US market is deciding the price of the car based on this engine size, horsepower, car width, drive, fuel type and car body. Based on these features, they are deciding the price of the car, right? This is our actual goal. We reached and we implemented linear regression. Now let me open my slides. Yes, we implemented the linear regression on the car price predictions. This is all about the session. Thank you for attending this session. I would like to meet you all once again in my next webinar with lots of interesting facts and information for your career. Thank you once again.